everybody, today we're going to take a look at adding metrics inside of a Nest.js application. We're going to use Prometheus to scrape these metrics from our Node.js app, and then we're going to export them to a Grafana dashboard so that we can see how our application is performing at all times and see how this data is persisted so that we can continually monitor our application, which is super important if we're ever going to deploy it into a production setting. So let's go ahead and jump right in and see how we can develop Nest.js metrics with Prometheus and Grafana. I'll see you there. Before we jump into the video, I just wanted to let you guys know I've released my new productivity app called Thrive on iOS, Android, and online at thriveapp.one. This app allows you to track your daily priorities, habits, and complete a daily journal, and will allow you to create notes as well so you can maintain productivity as you go through your day and only accomplish what matters most to you. If you'd like to check out Thrive, it's totally free. I'll leave a link in the description. Okay, so I'm sitting inside of a new directory where we want to create this new project, and I'm just going to run the Nest CLI here and run nest new nest, and this is going to go ahead and scaffold our new application. I'll use pnpm as my package manager. So after our package installation is complete, we can cd into our new project and run pnpm run start dev to start our development server that will recompile on change. Okay, so I've gone ahead and opened up our project in a code editor, and this is just a basic Nest.js application. We can see here we're starting up and listening on port 3000, and we have our single app controller here, which will be a get route that will just return a hello world string. So if we were to go ahead and open up Postman and execute a get request at localhost 3000, we can see we're getting back our response. So now let's go ahead and actually add a metrics route to this application so that we can scrape the underlying metrics and report this to Prometheus and Grafana. So we're going to use this open source package by Will Soto called Nest.js Prometheus, which is a Nest.js module for Prometheus that will export our metrics for us and give us all these great metrics around Node.js. So you can check out this repository here. I'll leave a link in the description, and we'll drop a star here because this is a great repository. And you can read more about this Nest.js Prometheus module, see what it does. But essentially, all we're going to have to do is install this package, register it inside of our app.module, and you can see by default, it's going to register a /metrics endpoint that will return us default metrics. Now, if you scroll down, you can also see that we have the ability to configure default metrics here, as well as injecting individual metrics, so we can easily add our own custom metrics if we so chose to. We can also change default labels and so on and so forth. But the defaults out of the box will be good enough for us. So let's go ahead and copy this installation command. So when you're going to install Nest.js Prometheus as well as Prom client, which is a Node.js Prometheus client. And we're going to go back into our terminal here, and I'm going to run pnpm install, and I will add these two packages here. So after we've installed these packages, I'll just go ahead and run start dev again here. And back in our editor, we'll go ahead and open up the app.module. And all we're going to have to do to set up the Prometheus metrics is import the Prometheus module and call register on it. And by default, we can just use the default options. And this is all we have to do. Now, if we go back to Postman and we make a get request at localhost 3000 /metrics, which is the default endpoint for this metrics module. If we send this request off, we can see we are now getting Prometheus metrics back from our application. So we get this valuable information, including CPU, user seconds. So we get Node.js event loop utilization statistics, which is an extremely important metric inside of Node.js. We also get active resources, active handles, so the number of current requests that our system is processing. We can actually get the actual number of active requests here. We get information about memory being used. So in general, we get a ton of great statistics around our app, including Node.js garbage collection as well. So this is all great, but out of the box, this is a bit hard to digest and it doesn't give us a great reporting ability. So we're going to actually export these metrics to a Grafana dashboard so that we can view them in a really nice way over time. So before we deploy this code inside of a Kubernetes cluster, which is how we're going to actually set up Prometheus and Grafana, I'm going to add one more file here. It's going to be a logging interceptor. And this is going to log out all the requests to our application. And so I'm going to paste in this code here, which I've gone over in a previous video on building out a Nest.js starter project. Essentially, all it's going to do is it's just an interceptor that will log out any HTTP requests and log out the current route, the correlation key, and so forth. So I'm going to include a link to this repository where we created this logging interceptor in the description if you're interested. But for now, this is all we need. And we also need to add UUID here to get the correlation key. So I will quickly install UUID here. And now back in the app.module, I'm also going to add a new provider here, which will actually be a app interceptor here, which will have a use class of our logging interceptor. So now we have a logging interceptor. If we go back to Postman and send off a couple of requests, we should see in our terminal, we actually see the requests logged out for our /metrics endpoint, which is exactly what I want to see. Okay, so we're ready to Dockerize our application here so that we can actually deploy it inside of a local Kubernetes cluster. So I'm going to create a Docker file at the root of our project. And I have a previous video where we go about actually building out a Docker file for a Nest.js application, and I go into each step in detail. So if you'd like to see that video, I will leave a link in the description where we built some Nest.js microservices, and I went over a Docker file in depth. For now, I'm just going to copy over that Docker file and paste it in here, where we can briefly see the steps to build this application. All we're going to do is copy over the package.json, run npm install, and then do the same thing in production mode. So we only get production dependencies, and then we start our node server with this command. And lastly, we're also going to add a .docker ignore file here, which will tell Docker to ignore any files which we specify. In our case, we're going to ignore the entire node modules directory so that we don't copy it over during this Docker image build. So after we've created our Docker file, I've opened up a new web page here and gone to Docker Hub. And I actually created a brand new Docker Hub repository for this custom image that we're building so that we can push it up. So you can feel free to go to Docker Hub, sign up, create a new repository, call it what you want, or you can use my existing Docker Hub repository here with the Nest.js metrics. So once you have a Docker repository that you can actually push to, we can run docker build, and we'll give it a tag here. In my case, we're going to use my repository, so I'll call it mgway Nest.js metrics. And then we'll provide the path to the Docker file, which in this case is the root folder. And lastly, make sure you have Docker running on your system, and we can actually build this image. So after our image has finished building, we're going to go ahead and push it up to Docker Hub by running docker push and provide the name of the tag that we just built. Okay, so now that we've actually pushed up our application to a Docker repository, we're ready to create a Kubernetes cluster where we have this application running, as well as Prometheus and Grafana to view these metrics. So I'm going to create a new folder in the root of the project called K8 to stand for Kubernetes. And then we will go inside of our terminal and cd into this new directory. And then we're going to use Helm as our dependency manager to be able to manage these dependencies inside of our Kubernetes cluster. I'm going to run Helm create Nest.js metrics, which is going to be our new Helm chart, which will describe how our application will run and all the dependencies inside of it. So we can cd into here, and then we'll open up this Nest.js metrics folder inside of VS Code. And we can see by default, it's created some templates here, as well as a default values.yaml, which are the overrides for the third-party charts and templates that we're bringing into this application. Right now, we can see we have a default chart.yaml with no external dependencies. Inside of our templates, we have some resources, define some Kubernetes resources. We're not going to use any of these, so we can go ahead and delete all of these default templates, as well as the tests folder inside of here. Then in our values.yaml, we can just go and remove everything inside of this file as well. So now we're ready to define our Kubernetes cluster and all the resources inside of it. I want to actually write a custom template for our Nest.js application here. So the easiest way to do that is on our command line. We can actually use kubectl, which is a command line tool to interact with our Kubernetes cluster. We can use this to actually define YAML for our template. So let's cd into the templates folder, and we're going to run kubectl create deployment, and I want to call this Nest.js metrics because this is our Nest.js metrics application. We're going to specify that the image here is where we pushed up to. So in my case, it's mgwe/Nest.js metrics. I'm going to say that it has a port open on port 3000 because that is where our container is listening by default. And then we're going to run dry run equal client. This ensures that we don't actually execute this command, but we are just wanting the resulting YAML from it. And then we'll specify here -o YAML that the output should be in YAML format. We're going to pipe this to a new file called deployment.yaml. So after this command is run, we should be able to open up a deployment.yaml file here with all of the necessary information to actually create this when we deploy our Helm chart. We can get rid of the status key here, as well as the creation timestamp. We can also get rid of the resources and strategy section here. Okay, so now that we have all the resources we need to deploy our Nest.js metrics application, we need to grab some third-party dependencies to actually run Prometheus and Grafana. And so I've opened up a new page here to artifacthub.io, and then we will search for Prometheus. And we can see there's a Prometheus package here. And you can read all about the description, the dependencies, as well as how to configure it and change any number of options that comes with this Helm chart, which is quite a bit. The most important piece here is scraping pod metrics via annotations. So we can see to actually get Prometheus to scrape pods, we have to add the following annotations to our pods, where we tell Prometheus to scrape it. We give it the path that we want to scrape on, which is /metrics, as well as the port for that container, which hosts the metrics endpoint. So let's go ahead and copy these annotations here. And back in our own Helm chart, before we install it, we can add these annotations by going down to the metadata, and underneath the label for the underlying pod, we'll add a new annotations section where we can paste in those Prometheus annotations, which will tell Prometheus to actually scrape this pod at /metrics, and the port, of course, here will be port 3000. So this is all we need to do to get Prometheus to scrape our application. Let's actually go back and see the version that we want to install. We can use the latest version here, 15.18.0. And all we have to do here now is get the repo URL. So in this case, it's prometheuscommunity.github.io. We will get this repository URL. And now we're going to open up our chart.yaml, where we can specify a new dependency section. So our first dependency here will have a name of Prometheus, and the version, as I specified, will be 15.18.0, and we will use the repository that we just copied, the Prometheus Community GitHub repository. And so now that we have Prometheus specified, let's go back and look for Grafana as well. So I see Grafana here, and this is going to be a Helm chart that we can get the URL for here. And now we will specify this in our chart.yaml. I'll give it a name of Grafana. The version field here will specify, and if we look at the version, we will use 6.43.5. So I'll give it a version of 6.43.5, and the repository here that we just copied over. So now every time we install or deploy this chart, this Helm chart we create, it will bring in these third-party dependencies that we need to expose our metrics. Lastly, we're going to open up our values.yaml here and actually make some customizations to these third-party dependencies. And that is easy to do with Helm. We just need to use the name we provide here and specify the values that we want to override. There are going to be a few additional services that this chart brings in that we want to disable because we don't want to use in this video. The first one will be Alert Manager. So we can say that this should not be enabled, as well as the Push Gateway. We don't need this as part of this chart. And lastly, the Node Exporter. I'm not going to enable on this MacBook, but you can feel free to enable it as well. It just will give you metrics for the underlying machine that you're using. In our case, locally, I'm not going to enable it. So now for Grafana here, we can specify if we were running in a public cloud like AWS or Google or Azure, and we wanted to run Grafana over an ingress and have a load balancer URL for that, then we could specify here that the ingress for Grafana, the ingress setting here, would be enabled and set to true. And then as long as you have a valid ingress controller running in this environment, your Grafana deployment will be available over HTTP on that common load balancer URL. However, since we're running locally, we can just access Grafana through a node port service and then access it on localhost. So to make this possible, we will edit this service property here, and we'll provide the type node port. So back in our directory here, I'm going to run helm install Nest.js metrics, and I'll provide the path to our Helm chart. And you can see here, we have an error saying we're missing in charts Prometheus and Grafana. So we can run Helm dependency update before to allow us to actually pull in these third-party dependencies. Now we should be able to run Helm install, and give it a second, we can see that our deployment was successful. And so now if we run kubectl get pods in our environment, we can see Nest.js metrics is starting up, as well as the pod for Grafana, a Kubernetes state metrics server, and lastly the Prometheus server as well is starting up. So if we get the pod name for Nest.js metrics, we can run logs and follow the logs for our Nest.js metrics app. And after about a couple of minutes, once Prometheus starts up, you can see our logging interceptor is actually logging out requests from that Prometheus/metrics route here. So we can see that it is actually completing successfully, and that Prometheus is starting to scrape this pod to get metrics from it. And so now if we were to run kubectl get service, we can see by default the Helm chart creates a Nest.js metrics Grafana service of the type node port because we overrode this. And then we can see the port here, the node port that maps to port 80 on the pod is 31791. So if we open up our browser and navigate to localhost here, 31791, or whatever port is your node port, we can see the Grafana login page. Now default username here will be admin. Now to get our Grafana password, this is stored as a secret inside of our Kubernetes cluster to keep it secure. So to get this secret out, you can run this command here to get the secret and echo it out to our terminal. You can see I now have this secret value. You can copy this and paste it into your login page. And now we have the Grafana dashboard here and the ability to browse and create new dashboards. So I've navigated to grafana.com/grafana/dashboards, which is a list of Grafana dashboards that we can freely install and use and import into this Grafana dashboard section to look at all kinds of metrics based off of Prometheus. So the one that we're going to look at here, if we search for Node.js, we want this Node.js application dashboard here. And we can see by default it works with Prom client, which is what our Nest.js Prometheus module uses. So we're going to copy this ID to the clipboard here. So we'll go back to Grafana here, and before we import this dashboard, we're going to go to settings down here, and under data sources, we're going to add a data source. We're going to add the Prometheus data source here, and then we need to specify the URL that Prometheus is listening at. So we can type in http:// and then paste in this Nest.js metrics Prometheus server name here, which is a cluster IP service, so we can contact it by name here and on port 80, of course. All of these default settings will be good enough for us. We can click save and test here, and then we can see that the data source is correctly configured. Now we can go back to our dashboard section. We'll copy this dashboard ID and we will import here. So we can say import via grafana.com with the dashboard ID. We will load this in, and we can call it whatever we'd like, Node.js application dashboard. And then we select our Prometheus data source here. So if we go ahead and import this now, you can see all of this metrics from our Node.js application. So for example, we can see in the last 5 minutes, the process CPU usage for our Node.js app. We can see the event loop lag, the number of active handlers and requests in total. We can see memory usage and all of this great information about our server. And lastly, what's really cool is that for any one of these metrics that we see here, if we want to further dig into it, we can open up this tab here and click the Explore button. I'll save this dashboard, the changes here. And now we actually are exploring on this Explore tab here, the Prometheus server and the actual queries themselves that this dashboard uses. So if we want to remove these, for example, and actually look at all of the different queries that we have, we can see that we just start typing Node.js, for example, we can get all of these raw Prometheus metrics that our /metrics endpoint is returning us. And what's great about this is that we can pull this range back, right, from days and days and have all of this information and data available to us. So I hope this was a useful video on seeing how we can incorporate Nest.js metrics into a Grafana dashboard. I plan on using this same video to implement horizontal pod auto scaling in a Kubernetes cluster in my next video. This is a super cool concept that will allow us to scale our application and add more pods as more demand hits the system and things like CPU and memory go up. We can add more copies of our application to cope with the load. So if you'd like to see this video, make sure you stay subscribed, and I will see you in the next one.